Now we are going to start today the new unit, that is unit 4, chemical bonding and molecular structure. Now students, you know that the matter is made up of atoms, right? Though the individual existing constituent particle is the atom, right? But its independent existence is not possible, right? In that case, we have to, at normal condition, it is not possible that the atom exists, right? So in that case, we have to discuss about the molecule of a matter. For example, if we take water, right, it consists water. It's formalized H2O. So it is a molecule which is made up of hydrogen and oxygen combined in a ratio, fixed ratio 2:1, right? So that means that the molecule has got an independent existence at normal conditions, that is the ordinary conditions. There are certain substances which are having the constant particle as ion. You can have the example which we generally use it every day, right? That is sodium chloride. Let's take an example of it. You know that the sodium chloride, it is made up of and sodium and chlorine, but the constant particles of it are Na plus and Cl negative, right? So here the two oppositely charged ions, right, they are being held in a molecule of sodium chloride. Whereas in water molecule or carbon dioxide molecule or ammonia molecule, there the atoms, right, the neutral atoms, they are being held together in a molecule. So this is the attractive force which holds the constituent particle, whether it be a atom or it be a ion, together in a molecule or a species or in a species, is called a chemical bond. So what is a chemical bond? It is a force of attraction which holds the constituent particles together in a compound or in a molecule of a compound, right students? Now a question will also come definitely in our mind, that why do the atom combines, that why the atoms are combining, right? And why is it so that they are combining in a definite number? That is, in water molecule, we have two hydrogen atom and one oxygen atom. In ammonia molecule, NH3, we have one nitrogen atom and three hydrogen atom. In carbon dioxide, CO2, we have one carbon atom and two oxygen atom. Similarly, we can have for the any ionic compound also, like NaCl, one sodium ion and one chloride ion. And if it is calcium chloride, it is one calcium ion and two chloride ions. So why is it so that a definite number of an atom or an ion uh, is being in a molecule, in one molecule of that compound, right? Now to explain this, we have got the two, you can say two facts are there, or two uh, concepts are there. The first is the energy, potential energy concept, and second is the Lewis Octet rule, that leads to that both these two both leads to the stability of the molecule, right students? So one is the natural, we can say a reason, or we can say it's a natural tendency of any we can say substance in the nature, right, or any molecule in a nature, or any being in a nature, living being or any substance in the nature, always tends to get the stability, right? So that stability is will be also observed in the chemical compounds also during their formation, right? So the stability is due to the decrease in the energy, right? The energy decreases. So whenever the two atoms or the ions they will combine, there will be always decrease in the potential energy, right? So whenever, as I said, the two atoms or more than two atoms will combine to form a molecule, there will always be a decrease in the potential energy of that system. The second is the octet rule. Now you have gone through the electronic configuration of different elements. You must have seen that the electronic configuration across the period it follows a definite order. There will be always increase in the number of electrons in a particular subshell or an orbital. One by one, the number of electrons are going to increase in the configuration, right? And ultimately, we come to the noble gases at the end of the period where we get the stable configuration, that is S2P6 configuration. So students, the noble gases, especially helium, neon, and argon. These three elements of the inert gases or the noble gases, they have got the stable configuration and they don't combine with any other elements to form a compound. They have got the stable outermost shell configuration. Whereas the other elements of the same group, right? Xenon, radon. There are certain compounds which are being observed, which exist or which are being made up, right? And we will go through it in detail that why the xenon is there, which form the compounds in the class 12. But till now, still for this class, we have to just go through that the noble gases has got the stable S2P6 configuration and every element always try to attain that configuration, and for that it is going to lose the electron or it will gain the electron or it will undergo the sharing of electron, right students? So till now what we have discussed here, the first is that the what is a chemical bond, right? So it is the force of attraction between the constituent particles, which can be either an atom or it can be an ion in a molecule of a compound, right? Then the second was the cause, that why a chemical bond is formed. The first is to gain stability by decrease in energy, right? So to gain the stability by decrease in energy, and second is to attain stable, this is noble gas configuration, right students? So to attain the stable S2 noble gas configuration, and second is to gain the stability by decrease in the energy. Now this rule, this stable S2P6 configuration is known as the Lewis, Lewis, Lewis octet rule, right? We will be doing it in detail later in this chapter, right? So this is there that the atoms combines to gain the stable noble gas configuration. I think this is not visible. to you. This is S2P6 configuration. This is the, I'm just writing here, the Lewis octet rule. Right, students? This is S2P6 configuration is known as the Lewis octet rule. Right? So we are going to discuss later on. Okay, one more thing is there. Whenever the atoms, two atoms will come closer, so what will happen, students? Definitely there will be the force of attraction between the nucleus of one atom and the electron of the other atom, right? And second will be the electron repulsion and the nuclear repulsion also. And to just uh, overcome this, right? So there will be, we can say the atoms are going to combine so that there is decrease in the energy. Here the energy is, students, the potential energy. Now you know that the potential energy is the energy stored. So if it will be released out, right, then only there will be the stability of that molecule of that atom, and to gain that stability only they combines to form a molecule. Morning, students. In the last class, we have started the new unit, that is the chemical bonding and the molecular structure, and we have just discussed that what is a chemical bond and why do the atoms combine. Now, the chemical bond is a force of attraction between the two atoms or more than two atoms in a molecule. And why do the atom combines? They combines to get the stable noble gas configuration. And second is that to acquire the lower state of energy. Right? Now, today we are going to discuss the types of chemical bond. Now, students, we have got mainly two main types of chemical bond. One is the covalent bond, and another is the ionic bond. Along with that, we have got the ionic bond and metallic bond too. So we are going to discuss first the ionic bond, and then we will discuss the other types. Now, in the ionic bond, now what is a ionic bond or an electrovalent bond? These are the bond, or this is a bond which is formed by the complete transfer of electrons from one atom to another atom so that a stable noble gas configuration is attained. Right? So in it, one of the atom is going to lose the electron and acquire the positive charge, whereas the other atom gains the electron lost by the first atom and it gets the negative charge on it. And then the two oppositely charged ions which are being formed, they are going to and attract to one another and get folded to each other. Now, what we'll start with the definition that what is a ionic bond or electrovalent bond. So, it is a chemical bond which involves complete transfer of electron from one atom to another so that each of these acquire stable noble gas configuration of outermost shell. That is, the outermost shell gets the acquires the nearest, that will be nearest to it, noble gas configuration. Now let's take an example that we have got an element A. It will lose the electron and it will form a cation is formed. Right? Now the next This is will be the gaseous cation. Similarly, the is another element B which will accept this electron and will get changed into B negative, and that is also a gaseous anion. Now this is the first step, this is the second step, and the third step will be that these two oppositely charged gaseous ions, they will be attracted to one another due to electrostatic force of attraction between the oppositely charges, and will form a stable compound, and this compound is the ionic compound. Since students here the ions are getting involved, so it is known as a ionic compound, right? And there is an exchange of the electrons so that the valence shell configuration gets stable, so it is a electrovalent chemical bond. Now students, we are going to discuss the electrovalent bond by taking few examples. Now we can take the formation of NaCl here. Now you know that, okay, now we'll discuss few examples. So first example is of the formation of NaCl, sodium chloride molecule. Now students, you know that sodium, it has got atomic number 11, so its configuration is 281, right? You can write down the condensed configuration also, that is neon, and then you can show the PS1 here for the sodium. It will lose its electron, and why is it doing so? So that it gets the nearest stable noble gas configuration of its outermost shell, right? That is NS2NP6 configuration, which is nearest to the, which is just similar to the neon, right? And in case if we have hydrogen and lithium, there the electrons are being exchanged just to get the doublet, that is they acquire the two electrons in the s subshell, right? Which makes its configuration stable just like helium, right? So in case of hydrogen and lithium, we will have the configuration, their tendency will be to acquire stable duplet, right? Which is just similar to its nearest noble gas configuration, that is of helium. So here students, one electron is being lost, it has got the sodium ion, that is Na plus, right? Similarly, we can have for the chloride, Cl negative. Students, here you know that it has got, chlorine has the electronic atomic number 17, so its configuration will come 287, or you can write down in condensed form argon, right? It has got, argon has got the 18 configuration, here it is 17, so you can just write it as neon 10, right? And then it will be 3s2 3p5, right? This one, so you can write it in this way, that is neon, which make it stable. This is 3s2 3p 5 to 10 11 12 12 plus 5 17. Now it will student, okay, here I haven't shown it, one electron is been lost, here I am showing it is accepting one electron, and it is forming Cl negative, and hence the configuration will be 288, that is it is acquiring the NS2NP6 configuration, which makes it stable configuration, and it resemble in its outermost shell configuration with that two argon, right? Now this is there. Now the third step, the Na plus which is been formed and the Cl negative which is been formed. These are the two oppositely charged ions. So the next step will be these two oppositely charged ions. They are going to attract one another and they will come closer and will form the NaCl. Right, students? So this is the steps for the formation of the sodium chloride. Now, students, you can do similarly for the other molecules also. Now, if instead of NaCl molecule, if we have taken calcium chloride, CaCl2, right? So, in that case, if it is CaCl2, right? So, you can, students, here first we will write down the electronic configuration for the calcium, right? So, here we have got calcium is how much? It is 20, so it is 2, 8, 8, 2, right? So it will lose the 2 electrons. Now students, now since you have gone through the ionization enthalpy, you know that these 2 electrons will not be lost at a time, it will be one by one, right? So it is calcium, calcium ion and the 2 electrons which have been lost here. Then comes the chloride ion, you know that one chlorine requires only one electron so that it gets the stable configuration, right? That is 287. So what about the another electron? So that means that the other electron which will be lost by the calcium ion will be taken by one more chlorine atom, right? And it will form one more chloride ion. That means here we can write it in this way that just again to write down the same equation, we will put here two chlorine atom. Will take the two electrons which are released from this calcium ion and will form two Cl negative. And now you can show the formation, that is Ca2 positive plus Cl negative, right? So you can write down two Cl negative and will form calcium chloride, CaCl2, right? This is the formation of the calcium chloride molecule. So students, just go through the other examples also where by just loss of electron, or we can say by the exchange of electron, a stable bond is been formed, that is the ionic bond or electrovalent bond is been formed.